Okay, so welcome everyone to week 8. So we are gonna also do the quick review for whatever we had in the last week. So let's start very quick. So we talked about the different type of conceptual database model, why we need this type of conceptual data model based on the organization that we are working, based on the different condition. We need this conceptual data model in order to capture the real world situation, in order to ask questions from the system, in order to write the queries. So we mentioned why these are so important, and we mentioned about the diagram that we can use in order to answer our question. We mentioned that just one picture worth a lot. It could save a lot of time and could definitely save a lot of energy to just read, for example, multiple pages to understand some business, but with just one diagram, you can understand how data flows through the organization. And then we talked about the different technique that we had. So we, as a famous, let's say, example that we always had in this class, the relationship between the book and the authors, different entities, the relationship between them. We mentioned that these are considered as a ERD or entity relationship diagram. But we mentioned that in order to have a better model, better techniques to draw a diagram, we decided to go with the object-oriented modeling. Object-oriented modeling is a technique for programming, and the only things that we are going to use from the object-oriented modeling was through the UML, Unified Modeling Language, or diagram, the class diagram that we mentioned, instead of the ERD. And we mentioned multiple times in the last session that ERD, entity relationship diagram, and the class diagram, they are the same, just the notation is different. And then we talked about the elements of the ERD and also the object-oriented one or the class diagram. So for the ERD, we had the entity. Here we had class. Over there, we have the entity instances. Here we have the object instances, and the relationship is exactly the same. Over there, we call it as an entity relationship diagram. Here we call it as a class diagram. And then just again, in order to presentation of these two for the object-oriented modeling, this is this model that we are presenting, just a slightly different in the ERD. And then we talked a little about the different type of class, lexical and abstract one. So for the lexical version, if you can write something, we call it as a lexical class. They're not a big deal to learn, but just understand it. And if we cannot write it, like the person, like the vehicle, like the, for example, I don't know, some department or organization, you cannot print it. This comes as a abstract class. And we mentioned when your entity, when your class is abstract class, you need to have the identifier. You need to have some surrogate key in order to uniquely identify those type of instances. And then we went a little further and talked about some type of relationship between entities, between the class. We talked about the generalization and a specialization. So I believe you should remember what's the generalization and specialization, supergroup and subgroup. Am I right? So any one of you would be volunteer to just a little talk about these two, generalization and specialization? Mm-hmm. Mm-hmm. Correct. Correct. So for example, we mentioned as an example of the academic system. So we can have that as a general group. We can have the employee. And we mentioned that, okay, we have, for example, in the academic system, we have two types of employee, the staff employee and faculty employee. So these two considered as a subgroup of this supergroup, a specialization group or generalization group. And again, the notation exactly the same between these two. And then we talked about the different type of relationship these could have. So we have complete, incomplete, and disjoint and overlap. So for example, one more time, in this specific example for the person, a student, employee, when the relationship between two can be overlapped, we can say this is an overlapping. So there is a possibility that some person at the same time is a student and also is the employee. So we can say there is a overlapping, but biologically the person, men, women. So there is no overlap between these two groups. So in that case, we can say there is a disjoint version between the two. And what's the difference between the complete and incomplete in this type of relationship? Sorry, the person is it the category for the complete? So what's the difference between the incomplete in these two? Yes, exactly. Exactly. Yes, exactly. For example, here the person can be student, employee, unemployed, not a student. So there's a possibility to have different group in this category. So there is incomplete. But here, definitely, there is no, again, biologically out of these two groups. So that's why we have the complete group as well. We are recording. And then we talked about the new concept as association. We mentioned that based on the cardinalities. Cardinalities between it means the relationship between the degree of relationship between the entities. One to many, many to many, zero to one. So we mentioned that. Okay, so this time we have issue with this one. Okay, we will talk on the microphone again. Yeah. So we mentioned that when we have the many-to-many relationship in the entities between the classes, technically this is not a good thing. In order to break down the many-to-many relationship, we have to use the association class. As an example, we had the student, we had the courses. Okay, so one student can take many courses, so there is a many-to-many relationship. And also one courses can be taken by many students. So technically there is a many-to-many relationship. In this case, we said it's better always to have the association class. Here we call it as enrollment. And the instances of this one is, for example, Hossein Mohit, take IS 3280. I don't know, Mr. 80 or whatever. Take, for example, HMI 7520. So this combination of these two could be considered as the instances of the association class. So that's one considered as an association one. As an example here, again, we have the employee in the system, in one system, that could be a supervisor or the worker. So supervisor supervises the worker, and also there is a complete relationship here, which means the employee there's no other two groups other than these two groups in the organization, but also there is no overlap between these two groups. Okay, so that's why we have the disjoint version as well. So the association also we talked, and then we talked about the cardinality or multiplicity. So in this case, we mentioned that, like the example we have here, a person has one social security number, and one social security number could be assigned to just one person. So there is a one-to-one relationship between these two. So this one in the right one is related to the person in the left, and this one in the left one is related to the social security number in the right section. So what we are just doing right now is just a reviewing. And here was the only difference between the object-oriented and also the entity relationship diagram, the notation. So in the object-oriented modeling or the UML, the ERD for the one, we for the zero, we show it with the zero. For the one here, we use one. Here, we have just one line cross to the relationship line. Here for the many, we have the asterisk. Here we have the crow's foot as a sign of the ERDs. Again, for the assignment 4, you need to use just the UML version, which means 0, 1, and asterisk. Okay? And then there is a maximum and minimum of degree of the cardinalities. For example, like the example we have here, if we have the uh, uh, minor person, so they don't have the social security number, so technically one person can have at least 0 and maximum one social security number. And one social security number can be assigned to at least 0% or 1%. So this is the way that we can show the minimum and maximum of level of the cardinalities as well. So this is in the object-oriented modeling. And for the ERDs, instead of 0 or 1, we can use this line and circle. Here, in this example, supervisor can supervise at least one worker or many worker. So we show that the one to many supervised by just one and only one. And we mentioned again in the class, this is for one specific organization. There might be another organization that one worker can be supervised by more than one supervisor. So in that case, you have to use also the one to many here as well. So again, based on different organization, it could be different. And this is the overview for the cardinalities. So all the things that we mentioned, the summary is here. And we talked again about the primary key and foreign key, the one that we have. And also we talked about the inheritance rule. So we mentioned that in the generalization and specialization group. So whatever relationship the generalization, the supergroup has, the specialization or the subgroup, they also have the same relationship and the same attributes. Okay. So as an example here, the generalization group, which is the person, the social security number, name, and address as attributes. Okay. And the specialization group, married person, we can just write the spouse name as an attribute, but technically, married person has 4 attributes, which is the social security number, name, address, plus the spouse name. But in order to just better representation, we will just write one attribute which is uniquely related to the married person in the graph, in the class diagram. And also the relationship all the same. Okay, so this is the just quick review for what we mentioned. Now in the D12, you see 2 type of files. One, which is the chapter 4 part, let me just, chapter 4 part 2 crows, and chapter 4 part 2 OO. So the crows version one is the one, crows version is the one that's related to the ERD, related to the entity relation diagram. And the OO is related to the object-oriented modeling. They are exactly the same file, just different notation. So here we can see the notation is related to the ERD, but for the object-oriented one, we can see this is related to the object-oriented or UML model. Okay, so as we mentioned, we are gonna continue with the object-oriented, with the UML. So let's go to this one. Again, the lecture video is available already, but we are gonna do it together in one more time, and then I hope we can have enough time today to review the exam one. Otherwise, we will review the exam one on Wednesday and also uh, with the assignment chapter 4. So technically what we're gonna cover out of these PowerPoints, by finishing this, you should be able to draw a diagram for assignment for easily. So let's do it step by step, learn it, and then we can definitely have a good understanding out of this PowerPoints. So let's start with this a specific example, okay? So this is a rule for the one bank. So here we can see in this example, a customer, one checking account, one saving it, okay? So this is the exactly like a model, like a class diagram that we have. And what type of relationship we can find between these entities? What are the cardinalities between these? So between the customer and checking account.
0 to many.
One customer can have 0 checking accounts and can have many checking accounts, and also the same for the saving account as well. But yeah, you were absolutely right. But let's go step by step. Assuming in this specific bank, a customer can have just one save checking account and also one saving account. So right now, each checking account can be assigned to just one and only one person. And this is the way that we can read it. When we say checking account to the customer, this number next to the customer is related to the checking account. Here, customer can have 0 to can have 0 checking account or maximum one checking account. The same for the saving account as well. So this is exactly a very, very uh, simple example of the class diagram. Okay. Now we can say that, okay, in this system that we are working, there is a possibility that one person can have multiple checking account or saving account, as you mentioned, and also checking accounts can be assigned to more than one person. A couple jointly, for example, open a checking account or saving account together. Okay. So in that case, a checking account can be assigned to at least one customer, to many customers, and a saving account is at least related to the one to many customers. The relationship between the customer to checking account, customer can have 0 or many checking account, and also for the same for the saving account. So is there anyone in this class right now that don't exactly get the point of this graph? All the numbers are clear, all the cardinality is minimum, maximum. If you have, yes, let me know. Okay, sure. Let's start from the checking account to customer. Okay, we will explore the relationship. The reason I am standing here because unfortunately my microphone doesn't work, so I have to talk with the laptop microphone. So I can stand here in order to have a better sound quality. Okay, so stay with me. So checking account, the customer. Okay, we can say that checking account is assigned, will be assigned to the customer. So at least one customer or more than one customer can have a checking account. Okay, there's a couple, they open the account jointly. Okay, so one checking account is assigned to more than one person. Other side, a customer can have 0 checking accounts or many checking accounts. That's the way that we can interpret this 0 here. Okay, so a customer can have 0 checking accounts or many checking accounts. The same here as well. Okay, so right now in this example, uh, between the checking accounts and saving accounts, imagine We have the account here as a generalization, checking account and saving account as a specialization. Is there a complete or incomplete relationship between the checking and saving and the higher level? We have the account here, we have the checking, we have the saving.
Could you have like an investment account?
Exactly. There is a possibility to have different type of account. I don't know, saving account, you mentioned investing account, I don't know, loan account, whatever. So there is a possibility to have more than two accounts. So there is an incomplete. Is there any overlap between these two? No. So there is a disjoint as well. One account at the end is the checking account or saving account. You cannot have both at the same time. Okay. So yes.
Is basically the minimum.
For the cardinalities, yes. Minimum maximum. Minimum maximum. So the example that I mentioned for the account, checking account, saving account, so we mentioned that incomplete disjoint. And also for the customer, so in the organization that they have, there is a human customer and organizational customer. In this system, there is no other customer as well. So in this case, we have the complete relationship. And also one customer at the same time cannot be organizational or the just a human customer. So there is no overlap between these two. So this is the disjoint version. And as again we mentioned, a specialization object inherits attributes of the generalization class. So in this case, the customer, the account, human customer, organizational customer as a subgroup over the checking account and saving accounts as the subgroup, as a specialization. And there is a relationship between the customer and the account as well. Customer can have accounts. Am I right? A customer can have at least 0 to many accounts. So with this 0 to many relationship, all these specialization group, they have the same relationship with the other group as well. So just the inheritance rule that we already knew. So nothing new. So what we are doing in this series of example, we first started with the different type of account in the organization, and then we said, okay, in the banking system, there is a customer as well. We are just expanding the class diagram together. Okay, now one step further. Customer can have 0 to many accounts assigned to one or many customers. Okay. So is this 0 to 0? What way we have 0? So right now, you can see in the first step, we had just this one as a class diagram. Now we are just step by step trying to enhance it. So this is exactly the way that you are gonna work on the assignment for the specific example that we have. And again, we will review it on Wednesday, and then after that, you will be totally fine in order to draw a diagram for assignment 4. Any questions so far? Yes.
So
There is no overlap between these two. So one more time here, the human customer, organizational customer at the end is part of one of these two groups. But for the overlap, Just always remember the academic example. The person can be a student at the same time and also can be an employee as well in the university system. So in that case, we have the overlap relationship between these two groups. So now let's go back to the RedCat database that we have in the chapter 2. We are gonna try to draw the class diagram for this specific example, okay? A specific data set that we have. So over there, we had some tables. For example, we had the same table, customer table, product table, manufacturer table, all the assignments that you did on the chapter 2. So you already remember all of these tables and also the attributes for each table as well. So let's class diagram for this database that we had. Okay, one of the points in the class diagram or ERD, it's better and most of the times it's kinds of the rule. You need to remove the foreign key from the tables. Okay, so here, for example, in the product table, we have the manufacturer ID as the foreign key. Okay, but here in the product table, when we try to draw the class diagram, we don't mention the foreign key anymore because when you are writing the relationship between the table, technically you are addressing it through the foreign key. Here, for example, product table is the manufacturer ID. Okay, so here we will say that the product manufacturer. Technically, you are addressing the foreign key, this time just with the verb that you have here. Okay, so in order to again make the class diagram more efficient, so you just remember this rule. Don't write the foreign key that it's available in the database schema into the class diagram. So that's the rule, just rule of thumb, remember it. That's it. So here, the table are here, okay? Sale table, product table, manufacturer table, and the customer table. Let's read this graph, this class diagram together, okay? So the sale includes some products, right? Each sale in this specific example, each sale is related to just only one product. Each product can be in the zero sale or many sale, and also the product can be made by one and only one manufacturer, and the manufacturer can make one or many products. And also here, each sale related to exactly one and only one customer, and each customer can make zero to many sales orders. So this is the way that you can write, you can read the graph, the class diagram that we have, okay? But in this specific example, there are some issue. First of all, it just assuming that each sale can have only one product, which is not right. The sale could be considered multiple items. Okay. And for example, for the product purchase, again, there could be an issue with the manufacturer. What is the issue? Here it mentioned that the product made by manufacturer, but we know that, okay, the product made by manufacturer, but you have to purchase a product from the manufacturer, okay? So that specific verb, the purchase, is not mentioned here, okay? So we are gonna try to this graph together better, okay? And also, we know that in the organization, there is also an employee. So again, step by step, we are gonna enhance that class diagram to have the final version. Okay. So employee, again, in this specific example, we have the two type of employee, wage employee and the salary. Okay. And between these two groups, is there overlap or it's a disjoint or it's a disjoint? Yes, because at the end of the day, employee is part of just these two groups. And for the employee version between these two, again, there is a complete relationship. So at the end of the day, it should be part of one of these two groups. There is no other group as well. That's just the question I wanted to ask. And also, in this type of model, again, we mentioned that employee, they can have the union relationship with itself. I'm employee, my boss is employee, my boss supervise me, his boss supervise him. So technically, employee has a relationship with the employee entity and to the class entity as well. So here we can say that the employee can manage zero or at least zero or many employees. And each employee can be managed by zero or maximum one. And in organization, what is this zero means?
You are the manager?
You are the, let's say, the top people in the organization. Let's say, for example, the CEO, the highest one. So that's why this zero means, otherwise it doesn't. Am I right? There is the one person in the organization, let's say just a private company. There is a one person that no one manage them. Okay, so it could be a CEO. So in that case, one of them can manage by zero. That's what this zero means in this specific example. So there are two ways to show this unit relationship. This one, the graph A, the relationship between the employee and the employee, and the other one, which is the graph B. This is the preferred method. So for the unit relationship, it is always better to look at the graph B because it's more, let's say, abstract. Here you need to draw two different type of entities, but here it's just one entity, and you are just showing the relationship itself this way. Okay, so this is the version that preferred. Okay, so we are again going step by step. The product for red cat shoes, there is a size for it. Okay, one product can have one, minimum one, or many sizes. One size can be assigned to one product or many products. So there is a many to many relationship. We mentioned that when we have the many to many relationship, what should we do?
Association.
We should break it down to different type of relationship. We should use the association. For the association, here we are naming as an inventory item. So technically, the product A with size, for example, 7, product A with size 8, product C with size 9, whatever, those instances are the instances of the association class. Okay? Any questions so far? When we see, yes.
Would you have a birthday?
Would we want the verb?
Or association kind of like implies it.
I don't understand.
Like if you were to put like a verb, like.
Oh, okay. No, at least, oh, no, we don't.
Okay.
Yeah, just wait. So we have the association class here right now, the inventory. Okay. The point is, when you have the association class, you can also have the relationship for that association class as well. So here, that inventory item, which is, for example, shoes type A, I don't know, the sandals with the size 2, size 7, size 8, can be considered in zero sales or many sales. Okay? So right now, we created one association class. The association class itself, at this moment, it has its own relationship as well. Okay? Right now, the inventory item can be in zero to many, and also one sale can have at least one inventory item to many. Again, there is a many to many relationship. So again, we need to have another association class, which is the sale item, we call it here, and we just name it with the quantity, okay? So for example, customer A, Jose purchase, for example, uh, sandals with size 7, how many? 3 pairs. So the quantity is 3 pairs can be considered the sale item as well. When you see the full picture of the uh, class diagram, it makes more sense for you. Now, let's add the purchase one. We mentioned that items made by manufacturer, but the point is we are purchasing those items from the manufacturer. So we have to address that purchase verb, that purchase action in the graph as well. So right now we can say the employee makes purchase. Employee zero or many purchase. And each purchase can be by one and only one employee. And the purchase made by the manufacturer, so each purchase can be made by only one and only one manufacturer, and the vice versa relationship is the zero to many. And here, the product on or many sizes. We are just going little step by step to adding more class to the diagram. And we are just creating different type of association. Here we have this purchase and inventory item. We have the purchase item as an association here, keeping the product. We have the inventory item as well. So this is the full version of the RedCat database. The most important part of this page that we are seeing with just a simple database that we have, just with 5 tables, very, 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 very simple database. We can see that this one considered as a class diagram. Okay. Now, at this point, imagine how would be the class diagram of the company like Amazon, like the company like Apple. Okay. So that's why having this type of graph takes a lot of time. Okay. In the organization, it is important. But let's try to understand this page a little more. Let's imagine you don't have any idea about this database. We mentioned that the most important and the main reason that we are drawing a class diagram, we are drawing the entry relation diagram is in order to better understanding of that specific business, right? So right now, when you are seeing this one and you have no idea about the business, okay? Let's read it from the top left. So here in this example, we can see, okay, there is a customer in this business. Okay, this customer made some sales. And with the cardinality, we can just understand what are the cardinalities here, okay? And each sale can have, it's related to how many items are available in that sale. So between these two, there is a association rule, sale. And each inventory based on the size related to some product. each product made by manufacturer create the product. And technically, you need to purchase those items from the manufacturer. So in the product, you can have this. And then that specific purchase made by employee. Employee makes the purchase. What is the purchase item? And also we can here see the relationship between the different type of employees that we have. In assignment 4 is for the uh, uh, like a healthcare system that we have. It's for the traffic healthcare system that we have in the assignment 4. There is a client, there is an employee, there is a consultant over there. Say just a physician or doctor, and there are some appointments making in that specific organization, that specific context that we have, and also different type of employees. You need to draw a diagram for that one. Again, we will review it on Wednesday. Very good. But this is the way that we can see how this one could be complicated when you have bigger organization, when you have bigger company, so you can have more comprehensive conceptual model. Okay. Any question from this graph? All the numbers are clear, the relationship, all of them. Let's see another example, this time in the university case, okay? So a student course, we already know that. A student and course, there is a many-to-many relationship, so we need to have the association. Association here is enrollment, okay? And again, we mentioned that association class itself, they can have their own relationship as well. So for this enrollment as well. For example, Hussein Mohit in IS 3280 received A. Okay, so there is a grade as well for this one. So let's say this is just the initial model. And then we can have the cardinalities between these two groups. And also in the university system, it's not just about the students. The professors also involved, okay? So professors can have 0 mini courses. Why 0? Because there are some professors in the business, in the university that they don't teach anymore. They are doing the administrative role, like for example, the president of the, or the dean of the college. They don't teach anymore. They just do the administrative stuff. So professor can teach 0 courses to many. Also, there is a possibility that the courses can taught with 0 to many it can be taught by 0 to many professors. For example, right now the IS 3280, just not this semester, previous semester, I was the only one that teaching this course. This semester for the online version, we have also another faculty as well teaching the IS 3280. So that's why there's a possibility, yes.
Whenever you're creating like a database, like there's specific code that you have to type in to like take into account for the cardinal.
For the cardinal, yeah, we will see later. Yeah.
It's a lot of work.
Oh, you mean in the SQL stuff?
Yeah.
No, there's no need for it.
You just gotta like do it.
Yeah, there's no need for it. Here we are just showing how the system works. That's it. No, in the SQL, when we are creating a database, no, there is no point for it. No.
So you like just the person inserting the data could like be set up.
Technically, there is no point by addressing that one in a database. When we are creating a database for the SQL, okay, these cardinalities is just for the class diagram or for the ERD in order to understand the business better. For the queries that we are writing in the SQL, there's no point of having this. I mean, it's not even related together. There's no there's no point. So again, many to many. So in that case, we have the association class, teaching assignment. So teaching assignment, assembly, teaching the ISM ability, uses textbook or it doesn't use the textbook. So again, you see, we can add as much as detail that we will find through all the interviews that we are doing in the business. So right now, again, students, courses, also there's a different section. There are different sections for each course. Here we are right now in the section 1. There is a section W01, which is the online version of this class, and also W02. So again, here we have another class or entity that we call it here as a section. And again, section related to the course number, course name. So we are just adding more. And also for the professors, there is a relationship for the professor with the sections as well. Each student can take, for example, one section of the course, and each professor can teach one section of each course. So on the two sides of the students and the professors, we have this relationship as well. And also there is a different type of fall semester, spring semester, summer semester, and also different type of year for the each term available. So right now we can see this is the full version of the class diagram for the organization, for the university system. So first of all, we start with the what is the year and seasons, spring, fall, summer, and then association is the term. Starting August to the December for the fall semester, and each term has multiple sections. Each section can be related to many students. Each section can be related to the service, and also section itself related to the different type of courses, and also here association class, teaching association class. So this is the one picture of the university, and for sure it's not complete because there is no involvement of the administrative rule. I don't know, for the graduate level, it could be more comprehensive. Graduate courses, undergraduate courses, so different type of majors. So this is just a general one in order to understand what does it mean by a class diagram. So right now, let's see this one. So, for example, one of the questions that we can answer with this one, we have two students in this specific example, John, Greg, that we have, and also one student did two different type of courses in two different times. One for the winter, for example, 2008, and winter 2009, fall of 2008. So we can see how the data flow here. What terms did John Gray take this sociology 101? You answer this one to me. What term did John Gray take sociology 101? How did you reach this one? I demonstrate the sociology. So, yeah, when we publish just yeah, I understand sociology fundamental. He take it in section 2, Professor name was Gady, and then he got B plus in this course. Also, that's the fall 2000. Okay, So also the grade, everything can be understandable through, I mean, achievable through this specific class level. So how we can answer these questions? What is the method for answering these two questions?
Query.
Query, SQL. Okay. You have, we have over almost 50,000 students at the KSU. So just imagine, for example, with simple query, you can exactly reach the grade of one specific student in one specific semester in one specific year. And just imagine you wouldn't have this tool to reach all these data for a specific information, for a specific student. That's why, as much as you have the better class diagram, you have the better database, and then you can have the better answer. That's why this class diagram is important. Again, we are in a system analysis and design class. You will learn more about the techniques in order to reach this type of information. You will see what type of techniques are available in order to interview. So that's the way that we can design a system. We are a couple of steps further in this class. Okay. So this is the way. So all of these are with more detail was in the YouTube video, but I also try to go through all of them in detail. Okay. So let's start we have 15 minutes. Let's start to review exam one, at least for some of them. And whatever left, we are gonna continue it on Wednesday. Good? Any question? No? So the main reason that I'm reviewing the exam one, again, not next week, from the next 2 weeks, we will start working on the chapter 6, which is the most important chapter in our course. And that's why I wanted to review one more time the exam one queries. In that case, you will have kinds of refreshing your mind. So make sure to open the advanced query editor on your side. Change the database to the MySQL. Let me see if it's checked. Yes. So again, go to the advanced query database MySQL and change the credential to the Lorenzo. Lorenzo was the one that you used in your first exam. Okay. So okay. So oh no. Okay, so this is the database to had for the uh, first SQL exam. So you had 5 tables in the exam. So customer table, shipment table, and truck table, driver table, and the city table with all related attributes. Okay. So for the first questions, give names of all customers that are retailer. Okay. So okay. So from the questions, give names of all customers that are retailers. So when we are saying that give the names of all customers, which means for the attributes that we are gonna see is just a customer name. I don't care about the other details. Okay. So for the customer name, we can see that here we have just the cost underline name in the table. So we would like to use the select from, select the customer name from which table. We are talking about the customer table when the customer type is retailer. Okay. So do you remember what was the order of the execution by SQL for the queries? How this one would execute it?
Customer table.
So yes, it will start from the from statements and then go to the second line. And at the end, it's gonna go to the first line, which is the select. So when we run the queries, we can see the names are here, okay? So if he uses distinct, is in this specific example, there is no difference, but when you are being asked, not just in the course, later, if you're doing this job. So about the name, about the some specific things that you don't want to know, for example, two Jose Mohits in the list of the customers. Just want to know my name once. So in this case, you always better to use the distinct in your coding as well. So the first one was the most and basic question that you could have. What is the customer ID and type of customer for the customer name Autoware INC? So it's telling us what is the customer ID. So you just need to have customer ID and the type of customer. So the customer type of the customer name. So this is the condition for us. We just want to have some specific information regarding this specific customer. And for sure, we are gonna just visit the customer table again. So select customer ID by customer type from the customer, where the customer name, Autoware INC. And we had multiple submission that they missed the quotation. Okay. One more time. Since this is the character, this is the string, we have to have the quotation for the Autoware INC. And if there was some, I don't know, part of the exam that you have a question, please at the same time ask. I'm assuming that at least you are, yes.
Actually, on that same question, it's also like one point.
Mhm.
Like, I don't know. Maybe it was the distinct.
Just one moment. There is a possibility. It happens previous semester. There is a possibility, some because of some, I don't know, software glitch or error, some points would be reduced from your grade. There is a possibility. Okay, I had some students that they had this issue last semester, so they just emailed me. I checked and I gave them the grade. Okay, so for this one, since we are going other questions, email me, okay, and I will check it if this is yes. It's
The grades for the exam.
your grades. By end of the semester, we're gonna transfer to the D2R. Yes, because I have to transfer it manually. Still, there is the school is working on the integration between those two. But over there, you can just check your grade. The only grade that's technically it's gonna created by D2L is the final exam, the final comprehensive exam that you are doing in the lockdown browser, and also the 5-point quizzes that you had for the first part of the course, and also that introduction part. Otherwise, the rest completely is gonna be through the D12. And then I will transfer all of them here for you. But again, if you think you did the right coding, just email me, I will check, okay? For your case, it says some issue with the casing. I don't know. I have to check it. Just email me, please. So, what are the truck IDs of the truck that have carried a small shipments? Truck ID. So we just need the truck IDs. Small shipments are defined as those that weighed less than 800 pounds. Okay, so there is also hint to avoid duplicates. So avoid duplicates easily. We can just use the distinct. So we are working with the truck ID. Truck ID is available in the shipment table and also in the truck table. But the point is we are talking about the shipments. So in this case, we are selecting just the unique truck ID from the shipment where the weight of the shipment is less than 800. And we had, I think, again, like this last semester, we had, I think, one or two submissions that they put quotation here. Okay, this is the number. For the number, we don't use quotation, correct? So okay. Give names of all customers who are not retailers. So name of the customer, so we need to use the customer name. And there are two ways. Most of the students answer through the first one. So we want to have the customer name from the customer where the customer type is not retailer. So where not customer type or retailer. Okay. So what is the other way to answer to this question? Hmm? So how we can show it?
Exclamation point.
Oh, like the one that you mentioned, the first exclamation point. Yes. You got the full grade, huh? So okay. Or the greater than and less than. Okay. Or like the one you mentioned, exclamation points and equal. So this is the way that we can also show as well. Okay. Give all the data for shipments weighing over 15,000 pounds. Okay. Give all data, which means all the attributes. Okay, there is no specific. So which means select asterisk is the first line that we would like to start with, and just easy. Mm. Select asterisk from shipment table where the weights are over 15,000 points. And if we want to have a 50 over 50 and also 50,000, which one is correct? This one or this one? This one? Yes. So greater than equal. This is the right, not the equal greater than. Okay. So these are just the small things, but if you don't pay attention, it's gonna be a problematic. So let's stop here because by end of this review, I also have a couple of more queries that I would like you to again do it in class for the same database, like the Lorenzo that we had, but more complex queries. So we will start on Wednesday by continuing for this six answer and those extra questions. and then we work on the chapter 4 assignments, and also we are going to draw a diagram for one specific example in class in order to make you prepare for the chapter 4 assignments. Any question? All good? Let me stop sharing. Hello everyone, welcome to second session of the week 8. So let's first finish the exam 1 review, and then we will work on chapter 4 assignments. So we were in this question 7. So create a list in alphabetical order of the names of the customer with more than 10 millions in annual review. So again, we just want to have the customer name, and also we want to have it on order. So we need to make sure to check the right column, right attributes from the right table or right entity or right class. So in this case, we need to use the select statement, same as always. So we go with just the customer name column, customer attribute from the customer table. And what is the condition right now? The condition is the annual review is over 10 million. Okay, so just greater than 10 million and ordered by customer name or cost name. So the default is going to be ascending, as you know. If you want to change it, you can just add the DESC as a descending, and then you can just reverse the order. So what is the name of the customers whose customer's ID is 989? So just another simple question. So again, customer name from the customer table, just one single condition where customer's ID is equal to 989. And as I mentioned on Monday, again, we had some submission that they put quotation around 989. So that's wrong. We know that if it's a number, we don't need to have it in the quotation. If it's a character, it's a string, we need to put it in the quotation, okay? So we can just easily know that the name is Hess Corporation. Question 9. What are the name of the customer having over $10 million in annual revenue who have sent shipment weighing less than 10,000 pounds? So again, we need to use the customer name. So since it's a customer name, also we can use it as a distinct because I don't care. For example, to Hossein Muhit is in the customer name. So we can use the distinct from which table? Customer table. Here we are using the alias. So customer, we are calling customer with the C. Then shipment, we are calling shipment with the S. And what are the, let me also at the same time have the table as well. So we are just going through the customer table to the shipment table. And the common key here is the cost ID. So cost ID here is the foreign key for the shipment table, and it's a primary key in the customer table. So just easy, we can just go through the customer ID through the customer table and the shipment table, and the annual review greater than 10 million. And the condition should use and or. Which one we should use? We know and. Why and? It needs to be both. And when we are saying and, one more time, let's just quick review. When we have A and B in the output, we are gonna see the output that meets these two requirements at the same time. So it should be at the same time over 10 million, and also it should be less than 10,000 pounds. And when we use or here, we are gonna have those that over 10 million plus those that less than 10,000 pounds. So here, since according to the question, it says to have sent shipments weighing less than 10,000 pounds and over 10 million pounds. It doesn't mention, for example, customers having over $10 million in annual revenue, as well as, for example, shipments weighing less than 10,000 pounds. So that's why we need to have to put the and as a condition, as a logical operator. Give the first and the last name, so first name and the last name of the drivers who have delivered shipment weighing over 10,000 points. Just another similar questions. This time we are going to select the first name, last name as attributes from the driver table. We are calling it as a driver as a D, and the shipment table S, where the driver ID in the driving table is equal to the driver ID to the shipment table. And the condition is the weight is greater than 10,000 points. So we can just easily see the name of the people here. Any questions so far? All good? And again, as I mentioned on Monday, sometimes it's possible the software on your side made some mistake, gave some glitch or error or something, and maybe you, for example, lose some point that you shouldn't. Check your grade, and if you think something happened like that, just email me. I will make sure to check it and give you the grade back if it's based on the mistake. So give the name of the customers in the city of Cleveland that have had shipments delivered by truck 3. Okay, so again, it seems we have two conditions, and both conditions should be true in the same time. So in that case, we need to use the AND condition. So we are going to have the customer name, okay, from the customer table. We are talking about the customer, so which means we have to address the customer table. We are talking something for the shipment, so we have to address the shipment. That's the way that we can translate the English to the SQL, as we already mentioned. And through the which customer table and the shipment table, through the which one, again, customer ID as a common attribute between these two tables. So in that case, we can see that the city should be Cleveland and the truck ID should be 3. And when I run it, oh my, so we will have the customer name Zbird and the weather truck cap and hitch. So these two customers that were in the Cleveland city and the truck ID delivered them is the number 3. So the last question of the exam, what are the name of the customers who have sent shipments to El Paso? Okay, so as we see, we are talking about the customers, so we have to address customer table. We have the shipment, so we have to check the shipment table as well. The condition we have is the El Paso. So in that case, and also we are specifically talking about the city, so we need to address the city table as well. So select customer name. Let's use the distinct in order to remove the duplicate. From the customer table to shipment table through the customer ID, and then joining the city table, which is the CI, and it's through the shipment to the city table through the again city ID, where the city name in the city table is El Paso. Okay, so that's the first 12 questions of the exam. Now let's do these extra 2 questions, and I need you to do it on your side first, and then we can continue working. But before starting, let me put these two together. So this is the table of the exam. No. Mm. Okay, so write a query, display customer name, truck ID, and the ship date for all shipments that were made using a truck with model year greater than 2008. And also make sure to use the alias on your side. Yes. No. But in general, especially when you have multiple table, you need to adjust each time, for example, from this table, joining this table, then. So always better to make your code shorter. So using alias in general, save space in the programming. And also make sure to just avoid any potential spelling error in your coding. Okay? So first of all, it's simple. It's telling us which attribute we want to see. Customer name, truck ID, ship dates. Okay? And for the shipment, so we need to go through the shipment table. So we have the shipment table here. It's all the customer. We need to address the customer table as well. And also truck with the model year greater than 2008. So we need to also address the truck table as well. So technically you are dealing with 3 tables for this query. Am I right? So make sure to start with the select statement. Use these 3 attributes, and then start from the customer table, going to the shipment table, joining to shipment table, and also joining to the truck table. And the condition is the model year should be greater than 2008. Okay? It's a simple question, but the reason I'm asking you to do it, because again, in the next 2 weeks, we are starting the chapter 6, the most important chapter in our book. So I just want to refresh your mind regarding the SQL code. It will just stay for a couple of minutes. And all the table names, attributes are here. Mhm. So that's the general structure for this one. Selecting those attributes, customer ID, whatever, from the which table. We are going from the customer table to the shipment table. Am I right? So what is the common key between these two? Customer ID. We are joining these two tables together. Then we are joining shipment to the truck table through the truck ID table. And then the condition where the model year is greater than 2008. Okay, so let me do it here. So as we see, we have the customer name, we have the truck ID, we have the ship date, okay? And we are going from the customer table. We are joining to the shipment table, okay? And then, so customer table to the shipment table, on which attributes through the customer ID, okay? Joining to the truck table, we call it with the T, on which attributes, truck ID attributes, where the model year is greater than 2008, okay? And as you see here, since we have, for example, truck ID in two tables, shipment table, truck table, we need to also address the alias here as well. For example, customer ID from the customer table, truck ID from the shipping table, and ship date from the shipping table as well. Shipping table as well. And so it's similar to the previous questions, just extra information. And at the end, it doesn't matter how many tables you are joining. Each extra table just asks you to have extra line of coding. Am I right? It doesn't matter at all. Okay? So in that case, let's do the second one. Write a query to display, again, customer name, truck ID, first name of the driver, and ship date for all shipments where shipment weight is greater than 5,000 pounds. The shipment was delivered to the city with a population over 3,000, and the truck's model year is after 2008. Seems complex, but it is not. Exactly the same as the previous question, just extra line. Make sure to definitely write this one for your side, on your side. And also let me just so we are talking about the customer name. Again, we have to address the customer table. We are talking about the truck. We have to address the truck table. We are talking about the shipment date. So we have to also address the shipment table as well. And also we are talking about the city with population over 3,000, which means we have to address the city table as well. So technically we are connecting 4 table, okay, except the driver. And if I had, for example, extra condition that, for example, with the driver ID of this and this and this, then you have to also address the 5th table as well. So again, starting with the select statement always. Here in this question, it's easy. It's telling us which attributes we need to have, so we can address those attributes. And then we are gonna go through the customer table to the shipment table, through the customer ID, and then we are gonna connect shipment table to truck table through the truck ID, and then shipment table to the city table through the city ID. And then we have, how many conditions we have? How many where logic we need to have? Logic in the where statement we have to have 3. So shipment weight greater than 5,000 pounds. So shipment weight is greater 5,000 pounds in the shipment table. City population over 3,000. City population in the city table over 3,000 people. And the truck's model year, it should be after 2008. Yes. Okay, so in this type of study into the table, always start with the question. The question's order is exactly the way that you can address, okay? And at the end of the day, it doesn't matter if you go from the A to B or B to A, okay? You just need to start from one table and joining the table to each other, okay? So here, it's easier off for us to start with the customer table and just going through the other table with joining function, with join functions. And that's the type of great questions. I would say this type of question as a critical thinking questions, which is why we are here. The main thing reason that we're here to just thinking in a different way, just critically thinking, okay? So that's the great question because you can do it on your side and start, for example, from shipment table, then joining to this table, and then do the rest of the process and check the result. In that case, you would definitely learn coding better. So again, customer name, truck ID, first name, and the ship date, those attributes that we need to have. So from customer table, let me close this one. So through the customer table, we are joining to the shipment table. We are naming them CS on which attributes, customer ID attributes, okay? Then joining to the truck table, truck T, so shipment table, truck ID equal to truck ID in the truck table, okay? Then joining driver, where is it? Okay, joining the driver because we also need to have the driver ID as well, okay? So then joining to the city table, city ID, and then weight is over 5,000, population over 3,000, and the model year over 2008. Okay, so just by running, we will have the truck ID, first name, ship date. Good. So in chapter 6, we will see, we are going to again review this type of join function again, but we will go definitely more advanced level. We will learn about the different type of joining. We'll learn about the function that we can use, and then one of the most important one, we will learn about using subqueries, which means query nested in another query, which is the most, I would say, interesting one. And it's gonna be a lot of fun. For over 3 weeks, we're gonna spend time, and after that, we're gonna have the second SQL exam, which is the 36 questions. It's gonna be a most interesting one in comparison with the first exam. Okay, yes.
That's like, could be like, you know,
You cannot separate them, you know. You cannot say, okay, now in the first part I learned select from join. So in the second one, you have to use a select from join. But for sure, it's gonna focus more on those more advanced things, subqueries, functions, left join, right join. You will learn. Yeah, and it's fun. So let me start working on chapter 4 assignments. Okay. So in chapter 4 assignments, Uh, gosh. Okay. In chapter 4 assignments, we have to draw a graph. Okay. Okay. So you're gonna design a conceptual model based on the class diagram. So first, before going further, I don't care how you draw it with the software. You have an iPad, you have the Apple Pen, you have whatever pen, or no, just drawing on the paper, take a picture, uploading for me, it doesn't matter. The things that matter for me is for sure the concept. Definitely, it's better to use the software in order to organize it better and more professional. But this is the way that you can submit your chapter 4 assignment. That's the only assignments. It's hand graded, so I will go through each of your graph separately and grade it. So select file and just submit your file, and just make sure to be a PDF or whatever graphical for PNG or whatever. Okay, so first, that's the case. Now let's read the assignment 4 together. Okay, and then if you have more question on each part, let me know. Richmond family, they have the therapy business, so it's a small family consulting practice. It's need an information system to schedule appointments. There are currently 5 counselors working on there. So this is how I would approach this type of question. So at this moment, I just found there are some counselor in this case. So I will just create a diagram, a class, an entity as a counselor, okay? Day facility also has 4 rooms, okay, that can be used for scheduling counseling session. So it seems we are gonna have another entity, another class. So room. Each appointment is scheduled for a particular date and has a start time and a duration. So it seems we are also having appointments. Okay, so appointment could be considered as another entity, as another class. So one more time, what's the difference between the entity and class?
That's just for.
Okay, and ERD, great. So it's the same, just different name. Entities for the ERD interrelation diagram. Over there, we are using right now OOUML, so Unified Modeling Language. So over there, we call it as a class instead of entity. Each appointment is for exactly one counselor and exactly one client. Okay, so it seems we have another class as well, which we call them as a class, as a client. And here we can see it's telling us about the cardinality. So each appointment is exactly for one counselor and exactly for one client. So now we can understand the relationship between these entities, okay, between these classes. Each counselor may have many appointments. So it's just exactly telling us the relationship between the counselor and appointments appointments class is one to many. And each client can have many appointments. So each client can have many appointments, and each appointment is exactly related to the one client. So there is a one-to-many relationship as well. Do you all agree? So each appointment is scheduled by an employee. Each appointment is in particular room, and each room can have many appointments. So technically, each room can have many appointments, but each appointment exactly assigned to only room. So there is again one-to-many relationship between these two as well. Additionally, appointments have two free text attributes. One is assignment, which is the description of what is the client may be instructed to work on in preparation for the appointment. It will need be able to hold up 2,000 characters. So here it's just telling us about the different attributes for each appointment, okay? Because in the entity relationship diagram, in the class diagram, for example, for the appointments entity or appointment class, you have to also mention what are the attributes as well, okay? Additionally, we were here, okay. So one is assignment, which is description of what client may be instructed for work, in particular for the appointment. It will need you to, okay. The other name is notes, and it's just a place for the counselor to keep notes about the counseling season. It will need able to hold up to 3,000 characters. So technically, these 2,000 characters, these 3,000 characters, it's for the next step when you are going to create a database. According to this graph, when you are creating a table for example, assignment attribute, you would use the CHR 2000 as the description of that attribute. So we will just tell software to reserve 2,000 characters for this specific attribute, okay? Here, technically, it doesn't matter to us. You are not going to address these 2,000s in your entity relationship diagram or class diagram, okay? Finally, each appointment has an attribute to indicate if the client kept that appointment. Appointment must be made in such a way that room's client counselor do not have time conflict. Of course, when a new employee, counselor, client, or room is added to the system, it will not have had any appointments, so it is possible for each to exist without being associated with a particular appointment. So there shouldn't be any conflict between the appointments as well. Employees, counselors, and clients are all people. Okay? So what does it mean just by this line? What type of specific thing we need to have in our I'm not talking about the surrogate key. Yeah. So right now, employees is one class. Am I right? Counselor is one class. Client is one class. So we have also the employee as well. It's telling us these three, they are all people. So what does it mean? How we can show it in our class diagram? Generalization and specialization, correct. So we have the generalized group, which is the people, and then we have three branches: employee, client, counselor, okay? So right now, when we go further, we can understand there is a overlapping between these categories. There is a disjoint relationship between these categories. Is this the complete or incomplete as well? These are the things that you need to address in your final graph, okay? So they will need a standard contact information. So technically, first name, last name, address, whatever, they are all the attributes for the general group, which is the people group, okay? In addition, you see, in addition, counselor have the degree suffix such as MD, PhD, and clients have found out attributes that allows a free text description of how client become aware of practice. So if you remember, we mentioned that in the generalization and specialization group, whatever attributes are in the generalization, the specialization would inherit. So it means those first attributes mentioned, like a first name, last name, those things, they are gonna address in the employee table, employee class. But additionally, for example, for the counselor, there is a degree suffix. So you need to address degree suffix just in the employee table. Okay. And also here, the method of the appointments, reminding, email, phone, text, whatever. In addition to a standard contact information, employee have the date hired attribute and the wage attribute. So in the employee table, we need to address the date hired, that the wage type also as well. Okay. Rooms have a room number and the room name. So this is the attributes for the room as well. So counselor in the firm are partners, not employee. However, it is conceivable that a counselor could be hired as an employee role as well. So it means there is a overlap between these two groups. There is a possibility that the counselor could be an employee as well. So it means there is a overlapping relationship between this group. Okay. So you're in class, so you deserve more than those people that are not in class. So we have people, we have client, employee, counselor, we have appointment, we have room. Okay. So this is the general graph that you need to access. Okay. Now you need to just write the right cardinalities between these groups, and also make sure to address, is it the complete, incomplete, disjoint, overlapping, and that's it. So that's the general things for this question. Okay. So, and then design your solutions such that it represent all basic content information in a single class, and use inheritance to combine the contact information with other attributes of the employee, client, and counselor, which we know what does it mean. Indicate which attributes serve as identifiers by underlying the attribute name. Do not include attributes to serve as a foreign key that information is captured by association. Remember that we mentioned on Monday. In the class diagram, we don't show the foreign key because technically the relationship between these two are showing. And you need to address this relationship with verb. For example, this room is reserved for this appointment, or this counselor assigned to this appointment. So make sure to just have the right verb, English verb as well in the relationship. Is it clear? Yes? So create a conceptual model consisting of object set, relationship, attributes, and so on, representing the above business case. Make sure to indicate cardinalities. That's the most important one as well. So is it a one-to-many, one-to-one, whatever? And technically, we shouldn't have any many-to-many relationship in our diagram. We know that's not true. So whenever you have later have a many-to-many relationship, it means you need to use the association class. Okay, great. So possible option for creating conceptual hand-drawn solution, computer-based drawing tool, powerful. Okay, so there are some software. Have you probably all have heard about the Microsoft Visio? Okay, you haven't? No. So in your Microsoft 365 that you have, in the online version, let me just show you. Yeah, just let me. So there is a Visio. Okay. So in Visio, exactly there is a UML class, but the point is in the online version, it's not free to use. But if you installed again, it should be on the Windows machine. Most of you have the MacBook, so you're gonna have problem. So in the Windows machine, when you download the Microsoft 365 and install it, it's gonna have this Visio, so you will have access to exactly the right notation. Okay, so this is the best way to create the UML design in a professional way. Okay, but I can also just use the regular PowerPoints. Okay, just inserting shape again. Just let's, for example, here we can say this is the employee and I don't know, first name, last name, just make them. And then you can group it if you want. Otherwise, just copy and paste. This time we have the client, different type of attributes, and just simply connect these together, and just by inserting a text box, for example, we can just mention write one and one. I don't know, one to many. So this is also a simple one, most simple one. And also there is another draw.io. So here, if you search UML, it's show you these, so you can have just drag it, change the name, write the attributes, okay, and just simply connect it as well and do the analysis. So this is also another one, and I think the book itself, it says there is a website, Lucidchart. This one also you need to just sign up and search for UML and have. Again, these are all in order to be more professional for your graph. But again, I don't want you to spend more time on these. You can just easily draw it with the pen or paper. But if you would like to be more professional, more academic, that would be great also to use through the software. And please, 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 I have had last semester couple of submission. They did just give the text to the chat GPT and just copy paste from the chat GPT. Again, I'm always said I'm not anti AI stuff. The only reason that I'm asking you, I need you to learn. That's it. You can use the chat GPT to give understanding, to have more idea, but make sure to draw it by yourself, please. Okay? And for sure, I gave them the 0 because they didn't even bother themselves to, for example, rewrite it, redraw it again. They just do the screenshot and it was super duper obvious that it came from the chat. So that's the exam assignment 4. Now we have still time. So let's do something fun together. So we have scenario, hospital appointment system, okay? The hospital system needs a database to track patient appointment. And I need a volunteer to come here and just draw it with me. Don't be shy. Yes, please. Good. Yeah, I think if no, of course. Let's use this one. Okay. So no, it's terrible. Let's do it back. Just use this part. Yeah. Okay, so let's read it together. The hospital system database to track patients' appointments. The system will store information about the doctors, patients, appointments, and rooms where appointments take place. So how many entities, how many classes we have at this point? 4, easy. Those that are in the bold font. So doctors, patients, appointments, and rooms, okay? Each patient can schedule many appointments, but each appointment is for exactly one patient. And then each doctor can have many appointments, but each appointment is for exactly one doctor. And then, so this is the room, good. And I would exactly address the doctor here as well. Okay, good. So far, so good. So let's have a cardinalities. Each patient can schedule many appointments. Okay, so
Over here on this side or this?
yeah, for patient to many appointments. So here we are using next one. So each patient can have 0 appointments or many appointments. Good. And each appointment is exactly for one patient. So if there is an appointment, is exactly for one and only one. Okay. Each doctor can have many appointments. So doctor to appointment, we will write it at the end. Okay. And each appointment is exactly for one doctor. Okay, good. And each appointments take place in exactly one room. So relationship between the appointment to the room is exactly one and only one. Okay, but a room can host many appointments. 0, yes, 0 to many appointments. Can have no appointments or no. So each appointment has a specific date, time, and duration. Date, time, and duration, correct. Doctors have employee ID, first name, last name, a specialization, and contact info. Just write their employee name, employee ID, and the first and last. ID, first name, last name. Patient also have the patient ID, first name, last name, first name, last name. Doctors have an employee ID, first name, as I mentioned, okay. Rooms have a room number and the room type. Number and the room type, okay. So technically we are done. The only things that we can also add to this one is to having the generalization and specialization. So doctors and patients, they are part of the people in this specific class diagram. So at this case, the person here is only can be patients, or it can be just a doctor. So there is a disjoint, there is no overlap. And the people in this system, they can also be employee as well, for example. So we can say there is an incomplete relationship. Okay, so that one also could be considered. We can have a let's say people here as well. So simple database, simple class diagram. Thank you, appreciate it. Simple class diagram, but the point is that's the whole process works. We imagine all these informations, attributes comes from multiple round of interview with the people in that organization, in that department, the multiple departments. And then according to those interviews, we can see how the data flow through this system, how this system works. We forgot something. What we forgot here? What we forgot here? The verbs, yeah. So doctor can be, your English is better than mine. Can doctor schedule appointment or doctor assign to appointment? Attends, why not? Okay. Patients can schedule appointment and room assign. Am I right? Okay. So this is also the verbs that we can. Good. And we have another example here, which is also the simple one. The library system designed to manage books, member, loan, and librarians. So another volunteer. Please. So we are trying to designing a database for the library system. So we have books, members, loans, and librarians. So technically, we just have four classes here, four entities here. So I would exactly do books here. I would probably do librarian here. And we also have the member as well. Okay. And then the loan. Okay, cool. So each book has a ISBN, title, author. Let's write the first two and title. Okay. And a book can be loaned many times. Okay. Can be loaned many times, but is only associated with one loan record at a time. So a book can be loaned zero or many. Am I right? And then loan can be assigned to only one and only one book. Two dots. Yeah, great. Okay. Each member can borrow many books, and the system track their first name, last name. So the member first name, last name, first name, last name. So it says each member can borrow many books. So we go to the loan because technically the action that are happening here is just a loan. Okay. So each member can have a at least 0 or many loan. 0, good. And each loan just would be assigned to one and only one person. And what are the verb for these? Book, to loan. Each book can be loaned. Maybe just use the loaned. We usually just use one verb, yeah. And member also borrow the books or something. And each loan also mentioned assign the book, and each librarian also manage loans and members as the unique employee. So technically, for each loan, there is exactly one librarian, but each there is a one-to-one relationship between these two. Am I right? Because the loan is exactly one action for one specific book. So, but no, a librarian can, yeah, can have multiple loans. So one and many, or 0 or too many, yeah, 0 too many. Okay, good. And again, we can have the librarian and the member as a people here. Yeah. And a librarian themselves, they can also loan a book for themselves as well. So technically, a librarian can be a member as well. So there is a overlapping relationship between these two. And that's it. Thank you. Appreciate it. So you see how it's easy to just draw a diagram for assignment 4. Next week, we will start on chapter 5. Chapter 5, we are going to spend just 2 sessions, Monday, Wednesday. And again, the next 2 Monday, which is gonna be, the next 2 Monday is a spring break, right? Yes. So, no? Yes.
Not next week, but the one after.
The next 2 weeks. Yeah. Yeah. Because I have a trip to go. So I already purchased the ticket. So yeah, next week, March 3rd and March 5th, we have class. And then next week is gonna be a spring break. And then after spring break, we're gonna start chapter 6 for 3 weeks. And then as always, it's gonna be a fun semester. Let me stop recording.
Where you going?